Yeah, hello everyone. I'm going to explain about blocking and non-blocking assignments topic in this particular presentation. I came up with one particular example. So yeah, coming back to me, I'm Bharat and I'm design verification lead and consultant. So, and the question I would be going to share today is about using blocking and non-blocking assignments in Verilog, right? So I have a question here. If you see this problem, the question is if initial values of A, B, C, D are 10, 20, 30, 40 respectively, after the execution of the following Verilog code, what will be the outputs of A, B, C, D? Here you have to observe certain things. Here you can see always it's a procedural block and it is triggered on every passage of the clock. You can see this is a particular assignment type. What is this assignment type? If uh, you can say that this is a uh, non-blocking assignment. If you see like the assignment is of equal to, that is called blocking assignment. Okay, now as I mentioned, I'm just trying to look for some pen or something to show you with the drawing here. Okay, anyhow, like this is a non-blocking assignment, and if you see only equal to, that is called blocking assignment. Okay, so yes, now okay, this is called blocking assignment. Okay. Now you are seeing on the question is after the execution of the following code, what will be the outputs of A, B, C, D, right? This is the question. Now I'm going to share the solution with the simulation, right? Here you can see I want to show the solution with the simulation, and in this I'm going to cover concepts always and initial procedural blocks, simulation and see the results, finally analyze what are the outputs. Okay, so I will be showing you through the simulation in EDA playground. I have created this small snippet of code. Here you can see module with ABCD as internal variables, and I'm generating clock here. This is a block where I'm generating clock, generating clock. Okay, so right, on every 5 nanoseconds the clock will be toggled. So here at passage of the clock I am assigning this one. Here I have a non-blocking assignment. As I mentioned, I'm just displaying whenever there is a change. So now I am killing the simulation after 50 nanosecond. Let me show you with the simulation, right? So any guesses what will be the outputs of A, B, C, D after this particular code ran? Okay, A, B, C, D. Okay, if you see here, A initial values are A 10, B 20, C 30, and D 40. Okay, like I'm running the simulation now, you can see this I'm saying. Okay, yeah, let's see what will be the output, right? So, first clock on first clock, right? First clock, okay, initially clock is 0. At 5, clock will become 1. Let's see. At 5 nanoseconds, clock became 1. Here, if you see, A is 10, and there at that clock means our interesting thing is whenever at first passage of the clock we were looking at. Okay, if he has a question like after 4 clocks or something, then it is different. Output will be here. Whatever it is here, you have to tell answer at this point of simulation time. But he has to uh, give the values at first passage. So first passage, if you see A is A, the same value. Always A is 10 and B is 10 assigned E at first clock. So if you see, we are assigning B A to B here in that first clock. So after 5 nanoseconds, we are assigning A to B. Okay. So at 5 nanoseconds, it's non-blocking. Immediately this will assign. Okay. At the same time, at the same timestamp, if you see, C will get B value. Okay. Even though B getting 10 here, but B here it is assignment is C equal to the immediate B value. Okay, immediate B value is, it is printed in hexadecimal here. If you see, okay, it is 20, right? Okay, so B got 20. Okay, right? C got B value. B's current value is 20, so immediately it will get assigned. So it's, as I mentioned, it's a non-blocking, right? So D got 30. That's way 0 A, B, C, D final values will be okay. If you see initial value at 0 nanoseconds, the values are okay. At 0 nanoseconds, I printed like this: 10, 20, 30, 40. Those are initial values, but we are looking at first passage. So first passage, A become 10, B become 10, C 20 and 30. This is the output. So our output is A 10, B 20, 10, C 20 and D 30. Okay. This is how the assignments will take place in Verilog. With that, thank you. See you in the next lecture. Thank you. Bye.